Dear students, now in the last session we studied about the subcooling, how we can bring about the subcooling. We discussed two methods for achieving the subcooling, and how the subcooling was improving the total refrigeration effect, and in a way it was improving the COP of the refrigerator. So now let us do a simple problem regarding such a matter. So let us read the question. A VCRS operates between minus 10 degrees Celsius and 45 degrees Celsius. The refrigerant is dry saturated at the entry of the compressor and attains 102 degrees Celsius after compression. The compressor bore equals stroke equals 8 centimeter and runs at 480 RPM with 80% volumetric efficiency. The temperature of the liquid refrigerant at the entry of the throttle valve is 35 degrees Celsius. So we need to find first one COP, second one mass flow rate of the refrigerant per minute, third one refrigeration capacity in tons. So in the question it is given, we need to use the refrigerant R22. So again let us read the question. So a VCRS is operating between minus 10 degrees Celsius and 45 degrees Celsius. What does these two temperatures mean? So these are the temperature limits between which our refrigerator will be working. So normally in the case of a VCRS or vapor compression refrigeration system, what will be the lowest temperature? That will be the lowest temperature maintained inside the refrigerator, or where is the lowest temperature normally maintained? In the freezer compartment or at the evaporator. Another name for the freezer compartment in VCRS is the evaporator. So the temperature maintained at the evaporator will be minus 10 degrees Celsius, and the higher temperature or the upper limit of this refrigeration cycle will be 45 degrees Celsius. What will be normally that our refrigerator, after absorbing heat from the evaporator, which is at minus 10 degrees Celsius, it has to reject the heat to the surroundings. Normally the temperature of the surroundings will be this or it will be rejecting the heat to the surroundings at 45 degrees Celsius. We are not saying that the temperature of the surroundings is 45 degrees Celsius, but the temperature of the refrigerant when it is rejecting the heat to the surroundings will be 45 degrees Celsius. And where does normally this 45 degrees Celsius will be experienced by the refrigerant? Normally when it is passing through the condenser. It is at the condenser where the refrigerant will be rejecting the heat to the surroundings. So first of all, let us try to mark these two temperatures in our refrigeration cycle. So let us draw the TS diagram and pH diagram. So temperature versus entropy, pressure versus enthalpy diagram. So first of all, you should try to read the question and try to draw these two diagrams. When you are able to complete these two diagrams, 50% of your work is over there and then and there itself. So first of all, let us start with the refrigeration step, or the most important step in our VCRS, the refrigeration step 4 to 1. 4 to 1 will be the constant pressure heat addition step. Okay, it will be a horizontal line in the TS diagram. Again, it will be a horizontal line in the pH diagram also. So 4 to 1. Then again, if we are then we can nothing is mentioned. Okay, so let us read the second line. The refrigerant is dry saturated at the entry of the compressor. At the entry of the compressor, what is the state of the refrigerant? It is given it as dry saturated. So where is the entry of the compressor? It is at the point 1. So it is given in the question that the point 1 is dry saturated at the entry of the compressor. So it means point 1 will be on the saturated vapor line. Okay, so that is why we are taking this point 1 at on the vapor line, on the saturated vapor line. Then 1 to 2 will be our isentropic compression process. So now let us read the question. Anything is mentioned about the compression process? The refrigerant is dry saturated at the entry of the compressor and attains 102 degrees Celsius after compression. So what does that mean? It was a isentropic compression. Since nothing else is mentioned about this compression process, we can assume that this compression process is isentropic. Okay, so the safest way to assume a compression process is to assume it as a isentropic process. So it is given here. The refrigerant is attaining 102 degrees Celsius after compression means, so 102 degrees Celsius normally it is a very high temperature. So normally it is representing the superheated state of that refrigerant. So we can draw a vertical line in the TS diagram, that is our isentropic compression process. So point 2 will be marked. So the point 2 will be marked on. So point 2 will be marked at the superheated vapor state of the refrigerant. So the temperature of at point 2 will be 102 degrees Celsius. So again 1 to 2 we can mark on the pH diagram also an inclined line for isentropic compression. So point 2 will be corresponding to 102 degree Celsius. So again let us read the question. The compressor bore equals stroke equals 8 centimeter. So now normally for easy representation, compressor can be assumed as a piston cylinder arrangement. So bore means the diameter of the piston cylinder arrangement equals stroke. What will be stroke? Length traveled by the piston inside the cylinder during one compression stroke. That stroke or that length equals 8 centimeter. Okay, and runs at 480 rpm. Means this we have already discussed in our air refrigeration system. The standard working of a compressor. A compressor will be actuated by a prime mover or a moving by a crank and connecting rod arrangement. That crank will be attached to a moving or rotating shaft, and that crank will be rotating at 480 revolutions per minute, along with 80% volumetric efficiency. This compressor cylinder is having 80% volumetric efficiency. What does that mean? The actual volume displaced by the compressor cylinder will be only 80% of the theoretical one. Okay, so we can mark that here. We can write it down here. The actual volume displaced by the compressor cylinder will be only 0.8 times the theoretical volume displaced. The theoretical volume displaced will be pi by 4 d square L, where L is the stroke length and d is the diameter or bore of the compressor cylinder. Now again let us continue reading. The temperature of the liquid refrigerant is the temperature of the liquid refrigerant at the entry of the throttle valve is 35 degrees Celsius. Okay, so what is the significance of that sentence? Now let us look here. Now let us try to complete our rest of the TS diagram or pH diagram. So now we have reached point 2. Now the point 2 means exit of the compressor cylinder, exit of the compressor, followed by the constant pressure heat rejection process at the condenser. So from 2, 2 3 now we can draw safely a constant pressure line. So 2, 3 we can mark a constant pressure line in pH diagram and in TS diagram also. So why there is a point 3 like this coming? Why there is a point like this 3 is coming here and an additional point 3 is coming over here? That is the explanation that is given in our question itself. The temperature of the liquid refrigerant at the entry of the throttle valve is 35 degrees Celsius. So normally if it was a constant pressure process 2, 3 so suppose if there was nothing else mentioned, what would have been the temperature at the entry of the throttle valve? Throttle valve is from 3 to 4. 3 to 4 is the throttle valve, or this isenthalpic expansion process through the throttle valve. So, or the throttling process. Throttling process is 3 to 4. So, entry of the throttle valve means 0.3. So, normally what is given in the question? VCRS is operating between minus 10 degrees Celsius and 45 degrees Celsius. So in the beginning itself, I have told you where the temperature at which the refrigerant will be releasing the heat to the surroundings will be 45 degrees Celsius. Or in other words, the temperature of the refrigerant when it is moving through the condenser will be 45 degrees Celsius. So this temperature at 2 dash and 3 dash will be 45 degrees Celsius. But here in this question it is mentioned the liquid refrigerant at the entry of the throttle valve is 35 degrees Celsius. Temperature is having the temperature of 35 degrees Celsius. So what does that mean? The temperature of the refrigerant is not the temperature of the refrigerant when it was moving through the condenser was 45 degrees Celsius, but it is given in the question that is at the entry of the throttle valve the temperature of the refrigerant is only 35 degrees Celsius. So the temperature of the refrigerant got reduced by 10 degrees Celsius after it has come out of the condenser, and that is exactly what is meant by this subcooling. And we have studied in the previous sessions how we can represent this subcooling process. Okay, so now we are recalling that idea, and using that idea we are extending the constant pressure line from condenser from 3 dash to 3 also. Okay, so additionally we are drawing a line 3 dash to 3. Okay, this 3 dash to 3 is a constant pressure line. Actually it is a continuation of this constant pressure line from 2 dash 3 dash, and here we are only extending that constant pressure line. So that 3 dash is the exit of the condenser and point 3 is the entry point of the throttle valve. So at the entry point of the throttle valve the temperature will be slightly lower than 45 degrees Celsius, which is at 3 dash and 2 dash. So now temperature at 3 will be 35 degrees Celsius. Okay, so how we can represent the subcooling in the pressure enthalpy diagram? Again, continue the constant pressure line from 2 dash 3 dash. Again extend that constant pressure line beyond 3 dash. So we can extend it up to 0.3. Okay, so anything else mentioned in the question? Now let us read. Okay, nothing else is mentioned in the question. No further details are given in the question. So nothing else is mentioned about the throttling process. So we can assume that it is a constant enthalpy expansion process or isenthalpic expansion process. 3 to 4 we can draw as a inclined line in the temperature entropy diagram. 3 to 4 will be a vertical line in our pressure enthalpy diagram, followed by the refrigeration step 4 to 1 over here also. So this is how we will be completing the TS diagram and pressure enthalpy diagram when we are reading the question. Okay, so with this idea let us move on. So now we have drawn the TS diagram and PS diagram. So now let us try to apply now let us try to use these two diagrams to solve our problem. Okay.